Hi all. In this video also I'll be explaining the determination of angles. So in this problem we have two smooth spheres as shown in figure, and the width of the vertical wall, width between the vertical walls is given as 360 mm. We need to find the reactions at the given points. So I'll just explain the angles in free body diagram. So I have drawn the free body diagram for the lower sphere and the upper sphere, and I have marked the forces. So here if you take the lower sphere first, then you have a contact point at point D. Here the contact surface is vertical, so the reaction will be perpendicular to that. So the reaction will be horizontal. So you have marked RD and it is a horizontal force. Then at C you have a contact point. The reaction at C will be perpendicular to the contact surface. The contact surface here is horizontal. So what will be the direction of the reaction? It will be perpendicular to that. That means it will be vertical. So RC is marked in the vertical direction. Now you have the weight. Weight is already marked 100 Newton. Then you have the reaction from the upper roller to the lower roller. So as mentioned in the previous video, that reaction will be acting through the line joining the centers of the sphere. Wherever two spheres are in contact with each other, the reaction between them will be acting through the line joining their centers. So here you have these points are centers. This is first point and this is the second point. So let me join these 2 points. Okay, so the reaction between the rollers or between the spheres will be acting through this line. So we need to know what is the inclination of this line in order to mark the angle. For that, the tip is to draw a right angled triangle keeping this as the hypotenuse. So you can construct a right angled triangle. See here, for this right angle triangle, this line joining of the centers will be the hypotenuse. So you have to construct a triangle like this, and this is the angle between the force and the horizontal. So this is what is required, theta. Fine. Now it is given in the question that the radius of the sphere is 100 mm. So if you consider this line, we can say that this much is 100 mm. This is the radius of one circle. And also if you consider this line, it is 100 mm because it is the radius of the second figure. Okay, and I can say that this length is equal to this length. So if you construct a straight line, this is also 100 mm. Okay, and we know that total is 360. So if you reduce this 100 and this 100 from 360, then you'll be getting the base of the triangle that we have formed. So we get that the base of the triangle is 360 minus 100 minus 100. That means it is 160. Okay, so the base of the triangle is 160. Now, what is the length of the hypotenuse? We know that we got the hypotenuse by joining the centers. So that means it is radius plus radius. So that is, it is 100 plus 100, 200. So in this triangle, the hypotenuse is 200 and the base is 160. Now from this triangle, if you take cos theta, you know that cos theta is adjacent side by hypotenuse. Adjacent side by hypotenuse. So what is adjacent side? Adjacent side is 160. And what is hypotenuse? Hypotenuse is 200. Okay, so when you find out cos theta, you can take cos inverse of 160 by 200. You'll be getting theta value as 36.87 degrees. Okay, so this is the value of theta, and this is the angle between the reaction between the rollers and the horizontal. So that means it is angle between RB and horizontal. So in both the free body diagrams, we can mark the angle between RB and horizontal as 36.87. So this is the method to be followed when you have contact between two rollers. You have to construct a right angled triangle keeping the line joining the centers as the hypotenuse. That is the clue. That is the point to be remembered. Okay, thank you.